Hello my friends, and welcome to the next video in this series where we shall be discussing numbers. In previous videos, we have already played around with numbers, but let's look at numbers in more detail. We've said something like let's first number equals 6. We can also say let's second number equals 6.8. This is an integer right here, and this is a float number right here. In other programming languages, these two numbers are quite different. This one is called an integer and represented differently. This one is called a float and represented differently. But in JavaScript, it doesn't matter. JavaScript treats an integer or float as numbers, so they have the same data type. They are all numbers. Now, let's go to our browser's console and work a bit with some operations that we can do on numbers. We're going to see some of the the very basic operations that we can do on numbers in JavaScript. Right here in my console, I'm going to say 2 plus 2, and we get 4. So this is the addition operator right here. The plus symbol is an operator, and we can use it to add two numbers together, and we get 4. Now I can say 3 minus 1. Right here, this is a subtraction symbol. And 3 minus 1 will give us 2. We also have the multiplication. You can say 2 multiplied by 3. And we get 6. So this right here is the operator we use to multiply in JavaScript. We also have the division operator, so we can say 10 divided by 2, we get 5. This right here is the operator we use for division in JavaScript. These ones are the basic operators and operations that we can do in JavaScript. We can also do exponents in JavaScript. So where a number, known as a base number, is raised to another number known as the power of the number. For example, 2 raised to the power of 3 will give us 8. And that is 2 multiplied by itself 3 times. So 2 multiplied by 2 multiplied by 2, like so, will give us 8. So, but we can represent this thing as a base number raised to a power. So we can say 2 raised to the power of 3. That is 2 multiplied by itself 3 times. So this is what we use to represent that exponent, and we're going to get 8. Let's also do another one. Let's do 2 raised to the power of 5, which should give us 32. And 2 raised to the power of 5 is nothing but 2 multiplied by 2, multiplied by 2, multiplied by 2, multiplied by 2. And we're going to get 32. So let's write 2 raised to the power of 5, and we get 32. We can also get a remainder in JavaScript using the modulus operator. So sometimes when we're dividing, we don't want to get the value of that division. We want to get the remainder of that division. For example, when we say 10 divided by 3, we're going to get 3.333 all the way down to 5 here. And that's because 3 does not go evenly into 10. But sometimes we just want to get a remainder. Remember, if you're going to divide this, we get 3 remainder 1, right? 3 can go into 10 completely 3 times, and then remaining 1. So sometimes we just want to catch that 1, and so we use the modulus operator. So we say 10 modulus 3, and we get 1. What this is saying is, give me the remainder of the division of 10 by 3. We can also say 20 divided by 6. We get 3.3 something all the way to 5, right? But if we say 20 modulus 6, we just get the remainder, which is 2 in this case. So this is the modulus operator, and we use it to get the remainder of a division. Now, let us talk about a bit more complex operations using numbers in JavaScript. Let's discuss precedence, and let's start right away with examples. I'm I'm going to clear my console. So I'm going to say 2 multiplied by 5 divided by 2 plus 5. What do we get? We get 10. How exactly was this determined? And if you were to work it up yourself, will you get this 10? Let's see how a computer actually solved this problem. So it first of all did 2 multiplied by 5, which gave us 10. And then it did 10 divided by 2, and we got 5. And so 5 plus 5 will give us 10. And that's why we got 10 printed on the console. Now, some other person might decide to add 2 to 5, first of all, getting 7, and then multiplied 2 by 5, getting 10, and saying 10 divided by 7. And 10 divided by 7 will give us something different from 10. So from this problem already, we can see that there is something called precedence in calculations. In my secondary school, we use a rule called BODMAS, which is bracket of division, multiplication, addition, and subtraction. So it means that our computer would first of all do a multiplication and then or division first of all, and then followed by addition and subtraction. This is just a very simple rule. But sometimes when we're coding in JavaScript, you can use parentheses to actually choose which operation is to get done first. So if, for example, instead of writing it the way I've written it like this, I can say 2 multiplied by, I open a parenthesis, 5 divided by 2. I close up the parenthesis and I say plus 5. What do we get? Oh, we still got 10. All right. And that's because, first of all, the computer did this division and it got a value, and then it multiplied that value by 2, and then it added it to 5. So in explicit terms, 5 divided by 2 will give us 2.5. 2.5 multiplied by 2 will give us 5. And then 5 plus 5 will give us 10. And so that's why we're getting 10. So this operation this way and this one will give us the same thing. Now let me bring out another problem. Let me say 2 multiplied by 3 plus 4 multiplied by 8 minus 2. What are we going to get in this case? We got 36. And how did the computer calculate this? So it first of all we do the multiplication. Right here is a multiplication, right? 2 times 3 is 6. And then he went over to do 4 multiplied by 8, and that is 32. So 32 plus 6 will give us 38, and 38 minus 2 will give us 36. Now, let me use bracket to section off this problem, and we'll see that we'll get a different result. So if I say 2 multiplied by, open a bracket, 3 plus 4, close the bracket, multiplied by 8 minus 2. Now you see, instead of getting 36, we're getting 110 for the same problem. It's just that I've now used brackets to section off a part of the problem. In doing calculations, or when you're coding and you have something to do with calculations, you should be mindful of precedence in JavaScript. So remember, we have brackets of division, multiplication, addition, and subtraction. Your multiplication and division will always come first, followed by addition and subtraction. And as we go along in this code, and when we use these examples or this skill in real-world projects or in basic projects, we're going to see how we put them together. Now, let's do a bit more manipulations with numbers in JavaScript. I'm going to clear out my console. We've already seen that we can store a variable. We've already seen that we can create a variable and store a number inside of it. So let me create a variable called age and assign the value of 19 to the age variable. I'm not 19, but then I just want to use this as an example. Now, this age has the value of 19. Ignore the undefined usually printed by this console right here. It is just its own thing. It is just a way of saying we've not done anything with this age, right? We just assigned a value of 19 to the age variable that we created. All right, so ignore the undefined. It is not the type of age. And in fact, if we check the type of age, we're going to see that it's a number. All right, we get number. And also ignore this dollar symbol that will usually appear here. It's just the browser's console thing. All right, so just focus on the value we're getting right here. Now we also know that we can reassign a value to an already declared variable. So for the age, I can say age equals 20. And now we now know that if I say age, I'm going to get 20 printed out on the console. I can also say age equals 22. And now age becomes 22. So that way I can reassign values, different values to my variable. Now, what if I just want to be increasing the age variable by 1 each time? So I can say age equals age plus 1. So what is this code doing here? We want to reassign a value to this age, right? And what are we assigning it? We're assigning age plus 1. In this case, what is age? Age is 22 at this point. And then when we add 22 to 1, we get 23. So as soon as I click enter, I'm going to get 23 right here. If I say age equals age plus 1, at this point, age is already 23. So when I add 1 to it, I'm going to get 24. And so it goes on and on like that. But there is a shortcut for this sort of addition, where we're just incrementing by 1, and we can also decrement by 1. So let me show us the shortcut. We can say age plus equals 1. So this code that I've typed out right here is just the same thing as the one I've typed out right here. This is just a short form of this one. So if I'm to increment the age by 1, I'm going to get 25 on the next line. And I can also do the same thing to decrement the value. So I can say age minus equals 1. So now, instead of incrementing, I want to decrement by 1. So as soon as I click enter, I'll get the value of 24, because 25 minus 1 is 24. So that's why I'm having 24 here. This also works with division and multiplication. So if I want to say age multiplied equals 2. So I want to multiply my age by 2. What is the current age? It is 24. And so that is 24 multiplied by 2. And then it gets stored back inside of the age variable, right? So I'm going to say that I'm going to get 48. I get 48 here. And age is 48. Okay? The same thing with division. So I can say age divided equals 2. I want to divide my age by 2. So that is 48 divided by 2. I will get 24. And that 24 will get reassigned to the age variable. So as soon as I click enter, I'm going to get 24. And age is 24. So sometimes this shorthand comes in handy. Instead of just writing out something like age is equals age plus 1 or plus 2, we can just say age plus equals 2. Okay, so this shorthand can come in handy, and we're going to get 26, because remember the last value for the age is 24. And so I'm incrementing the age by 2 and I'm getting 26. Now let's talk more about float numbers. I'm going to clear out my console. At the beginning of the video, we talked about the kinds of numbers that we can use in calculations. So we have the integer, like this one right here, and we have floats, the ones that have decimal points. Computers understand or interpret or use float numbers quite differently. So if, for example, in my console, I say 0.2, which is a float, plus 0.3, I'm going to get 0.5, and this is accurate, all right? But sometimes floats mess around with computers. So computers find it a bit tricky to work with float numbers. Now, I did this basic addition, 0.2 plus 0.3, and I'm getting 0.5. But let's see what happens when I say 0.1 plus 0.2. Now I get this funny looking number. Instead of getting 0.3, I'm getting 0.3, 0, 0, 0, 0, and all the way to 4. This is quite inaccurate. The reason why this sort of thing happens is because of the way our computer understand or interpret or use numbers. And it only happens with floats. For integers, there is no problem. So when you say 6 plus 6, there is no problem at all. But sometimes with some floats, not all of the floats, with some of the float numbers or float values, our computer tends to mess around a bit, just like it did when we tried to add 0.1 to 0.2. And the reason for it is that our computer stores numbers or data generally in zeros and ones. I'm going to demonstrate what this means exactly. Right here is a binary to decimal converter. So remember I said that computer understands binary, that is zeros and ones. But then we as humans, we use decimal values, okay? Now, let's convert a particular decimal value to a binary. So I'm going to choose decimal, and then right here I'm going to choose binary. So I want to convert from decimal to binary. And what is the decimal number that I want to convert? I want to convert 0.2. Now let's see what 0.2 in decimal gives us in binary. Now 0.2 in decimal gives us 0.0011, 0011, 00, all the way to this 11 right here, these long values. And you can see they're all in zeros and 1. So this is a binary representation of 0.2 in decimal. Now I'm going to copy this number, which is a representation of 0.2, and try to convert it back to decimal. So I've copied this value. Now let me choose to convert from binary to decimal. And right here I'm going to paste in the binary number. So this is the binary number we just got now. So I want to convert this number back to 0.2. So let's see what it gives us in decimal number. So as soon as I click on convert, I have this 0.199 all the way to 5. Why is this so? This is inaccurate, right? Because we're supposed to get 0.2. But that is just because of the way computers tend to work with floats sometimes, some of the floats. So we should just pay attention to this. And fortunately, JavaScript as a language has given us some tools to also work with numbers, including decimals, and try to make sure that we get accurately what we want to get. So back to our browser's console, I'm going to show us some of the functions, built-in functions, that JavaScript has provided to work with numbers in general, especially floats numbers. I'm going to clear out my console. And now, the first function that I want to work with is what we call math.floor. So, we've not yet talked about functions in JavaScript, but then it is good enough to know at this point that they just do something in particular. They just provide us with some services, if you like. So in this case, we are using math.floor. Remember, we used some functions such as console.log, document.write. In this case, let us see what math.floor is going to do. So let's say math.floor 3.8. And when I click on enter, I get 3 back. This math.floor will give me the integer part of a decimal or float number. So even if I say math.floor 3.9, 999 and close this off, I'm still going to get 3 back. So it just gives me the integer part of the decimal number. Now let's look at math.ceil and type the same 3.8. We're getting 4. So what math.ceil will do is to round off this number, okay, properly. Since it's already 3.8, it's going to give us 4. So it's going to round it off to the nearest number, to the nearest whole number. If we had said math.ceil and we provided 3.2, we're getting 4 back, because it doesn't matter whether this is 3.2 or 3.8 or 3.7 and all of that. It's just going to give us the next integer. So in case of math.floor, it rounds it off to this integer that it has right here. But in math.ceil, it gives us the next integer. So even if it were math.ceil 3.00011, it's going to give us 4 back. All right, so it gives us the next integer. What about math.round 3.2? You can think of math.round as a combination of math.ceil and math.floor, because it's going to round it off appropriately to the nearest whole number. In this case, 3.2 is closer to 3 than it is to 4. So we're going to get 3 back when we use math.round. But if you were to say math.round 3.7, for example, 3.7 is closer to 4 than it is to 3. So we're going to get 4 back. So these are some of the functions, built-in functions, that we can use to work with some float values. Another useful function that we can use to work especially with float numbers is called math.random, and it's just used to generate random numbers between 0 to 1. So I say math.random like so, and it prints a number to the console. In this case, it generated 0.2172 all the way to 6. If I should run this code again, let me copy and run this code again, I'm going to get a different float number. In this case, I'm getting 0.14 all the way to 2. And if I run it again, I'm going to get another random number. In this case, 0.09 all the way to 0.8. So we are all getting float values when we run this math.random function. And remember, it's just generating values between 0 to 1. What if we wanted to generate a value between 0 to 6? So we can say math.random multiplied by 6. In this case, it's going to generate random number between 0 to 6, but not including 6. So when I run this, you see we start getting 2 point something. Let me copy this code and run it a few more times. Here we get 3 point something, we get 5 point something, we get 0 point something, we get 3 point something, but we're never going to get a 6. All right, so it will go from 0 all the way to 5 point something, 5.999, something like that. But then they're all random numbers. Okay, so and then they're in floats. What if we wanted to round these numbers in some way so that we just get a whole integer instead of getting the floats? So a function that we can use is math.round. So we can use it to round off the number to the nearest whole number. So I'm going to first of all say math.round and open the brackets. And then within these brackets, what do I want to round off to the nearest whole number? I want to generate a random number, right? So I'm going to use math.random Remember to add the parentheses. Then add the random multiplied by 6. So in this case, first of all, I'm going to get whole numbers, no longer float numbers like we've been getting before. And then the numbers are going to be between 0 to 6 because we're using round here, right? If we get something like 5.2 from this code, then the round function will round it off to 5 because that's the nearest whole number. So the numbers we're going to be getting in this case will be from 0 to 6. So in this case, we got 3. So let me copy this code and run it a few more times. We're getting 3 again. We're getting 6. We're getting 5. We're getting 2. We're getting 2. 6. And so on and so forth. So it's just random, right? So we're getting random numbers. So these are some of the useful math functions that we can use to work with numbers in JavaScript. Next up, we're going to see strings in JavaScript. Please remember to like my videos, share them to your friends, and subscribe to my channel if you like my content. See you in the next video.